This is Jack Jackson. In this video, we're going to talk briefly about connections of geometry to other areas of mathematics. First of all, there's obviously a connection of the study of college geometry that we've been doing in these set of videos and in my textbook and in my course to the study of geometry in elementary, middle, and high schools. In fact, much of the material that we've done in my text and in these videos uh, and my GeoGebra activities can be used in a good high school geometry class, and some of the more basic introductory material throughout the text and in the videos is even appropriate for upper elementary and middle school students. In this chapter on transformations, we've also made many connections to other areas of mathematics. So applying the techniques of this chapter, we've seen how to transform graphs of functions and relations in general. These are topics that are studied in high school and college courses in algebra, trigonometry, and pre-calculus, perhaps in calculus. Conic sections and continuous functions are studied in the calculus sequence, calculus courses, and perhaps in pre-calculus courses. Looking at transformations represented by matrices connects transformational geometry to linear algebra, and in particular representing transformations with 2 by 2 matrices introduces a vector space structure. Using the 3 by 3 matrix representations of transformations induces a group structure, and algebraic groups are studied in abstract algebra and group theory. Symmetry groups and their representations as permutations and cycle notation is a part of the group theory portion of any good abstract algebra class. The last chapter should be a part of a good introductory course in abstract algebra as well. The study of the history of geometry is central to the study of the history of mathematics. Historically, geometry was the first area of mathematics that was studied rigorously. Writing proof was first pioneered by the ancient Greek mathematicians in their study of geometry. Writing proofs is mathematics, and reading and writing proofs permeate the mathematics courses, especially courses such as discrete mathematics, foundations of mathematics, abstract algebra, real analysis, topology, and of course, geometry. So anything that we did about writing proofs is going to be at least some way connected to that. Much of mathematics is interconnected, and the study of geometry links much of it together. We've covered a great deal of foundational geometry in this course. If you've been watching and studying all of my videos in these playlists that I have on geometry, we've covered a lot of geometry. I encourage you to continue your study of geometry. Um, there are many uh, things in geometry that we did not have a time to get to, but we covered a lot of the basics. In any event, I hope that you can leave this course or leave this set of videos online confident that you've learned a significant amount of geometry, that you're confident about teaching geometry in secondary school, and you've achieved other course goals, and that you have grown as a mathematician. Farewell.